Today we'll look at elastic collision. Previously we looked at the kinds of collision as one, elastic collision, two, inelastic collision. Just to refresh our memory, elastic collision is a type of collision where both the momentum and the kinetic energy are conserved after the impact. In the case of inelastic collision, the kinetic energy is not conserved. So let's look at a scenario where we have a body A that moves with initial velocity UA and has a mass MA, and a body B and moves with an initial velocity UB and has mass MB. This is before collision. After collision, what happens? Body A moves with a final velocity VB and a mass still MA, and body B moves with the same mass and the final velocity is VA, VB. So the momentum before collision will be MA UA plus MB UB equal to MA VA plus MB VB. So in terms of kinetic energy, what happens? We write this in terms of kinetic energy. We can write this as half MA UA squared plus half MB UB squared equal to half MA VA squared plus half MB VB squared. This is in terms of kinetic energy, because the two of them, both the momentum and the kinetic energy, are conserved. So we have a problem here. A 5 kg object traveling at 1 meter per second collides head-on with a 10 kg object initially at rest. Determine the velocity of each object after the impact if the collision is elastic. So let's look at this. M1 is 5 kg, U1 is 1 meter per second, M2 is 10 kg, and then U2 is 0, because they say initially at rest. So using this principle, we can write this as M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So by the time we substitute, we have M1 is 5 times 1 plus M2 is 10 times 0, because U2 is 0, equal to M1 is 5 times V1 plus M2 is 10 times V2. So of course 10 times 0 is 0. So we now have 5 equal to 5V1 plus 10V2. Of course, we can reduce this equation in such a way that we can handle it properly. So this is the left-hand side of the equation. and this is the right hand side. By the time you divide through by 5, that is 5/5, whatever you do to the left hand side must be done to the right hand side, equal to 5v1/5 plus 10v2/5. Of course, this will be reduced to 1, equal to v1 plus 2v2, which is equation 1. It's an equation that we must solve because we have two unknowns here, v1 and v2. This is in the terms of momentum. What of terms of kinetic energy? In terms of kinetic energy, we now have half m1 u1 squared plus half m1 m2 u2 squared equal to half m1 v1 squared plus half m2 v2 squared. This in terms of kinetic energy. But it will be more appropriate if we write this as half, because half is common. m1 u1 squared plus m2 u2 squared equal to, on the right hand side, half is also common. So we have m1 v1 squared plus m2 v2 squared. So we now substitute the value of m, u1, m2, u2, and like that. So we now have substituting these values, we have half into m1 is 5 times u1 is 1 squared plus m2 is 10 times u2 is 0, that is 0 squared, equal to half again into m1 is still 5 times v1 squared plus 10, which is m2 times v2 squared. So by the time you evaluate this, we have half. If you square 1, it's still 1 times 5. 5 plus square 0, 0 times 10 is 0. So we have this. So we now have half into 5v1 squared plus 10v2 squared. So we can write this as half times 5 equal to half into 5v1 squared plus 10v2 squared. Of course, we can, instead of working with this half, we can do away with the half by multiplying both sides by 2. So if you multiply both sides by 2, we have 2 times half times 5 equal to 2 times half into 5v1 squared plus 10v2 squared. So where this will take care of this, as a 2, I will have an equation as 5 equal to 5v1 squared plus 10v2 squared, which this can still be reduced. Divide through by 5, we now have 1 equal to v1 squared. Let's do it in such a way that everybody will understand. Divide through by 5. So this becomes 1 It becomes V1 squared plus 2V2 squared. And this is equation 2. So we have two equations here to solve. And what are we solving for? V1 and V2. We have two unknown in these two equations. So that is equation 1 is 1 equal to V1 plus 2V2. That is 1. And equation 2 is 1 equal to V1 squared plus 2V2 squared. That is equation 2. So if you want to solve by substitution, so in equation 1, we'll make V1 the subject and substitute into equation 2. And then later find the value of V1, V2 I mean. So from equation 1, we'll make V the subject, and V1 is equal to 1 minus 2V2. And that is our equation 3. So we'll now substitute the value of V1 into equation 2. So substitute equation 3 into equation 2. That is, this is our equation 2. 1 minus V1 squared plus 2V2 squared. That's our equation 2. So we'll now substitute. This becomes minus, instead of V1, we'll now have 1 minus 2V2 all squared plus 2V2 squared. So by the time we expand this, we now have 1 minus 2V2, 1 minus 2V2 plus 2V2 squared. So we'll open the brackets and we'll have 1 minus 1 times 1 is 1. 1 times minus 2V2 is minus 2V2. 2V2 times 1 minus 2V2. And minus 2V2 times minus 2V2. This will give us plus 4V2 squared plus this 2V2 squared. Of course, these are like terms, so we can add them up. So we have 1 minus 1, is that right? Minus 2V2 give us minus 4V2. Then this becomes plus 6. That is 4V2 squared plus 2V2 squared. 6V2 squared. Is that right? So this is, remember, we have this. This is our equation. This is what we substituted. This equation 3 into equation 2, which is 1. This should be 1 equal to. So from here, we can take this to the other side. This becomes 0 equal to minus 4V2 plus 6V2 squared. And we can write this equation as 6V2 squared minus 4V2 equal to 0. So we can factorize this. What is common is what? 2. 2V into 3V. 2V times 3v will give us 2v2 times 3v2 will give us 6v2 squared minus 1 equal to 0. So if you open this bracket, 2v2 times 3v2 will give us 6v2 squared minus, so this should be 2. So if you multiply this by this, it will give us this. So we can say that 2v2 is equal to 0, or 3v2 minus 2 is equal to 0. So if this is equal to 0, so we can say that v2 is equal to 0, or 3v2 minus 2, or we can take this right side, it becomes 2, so v2 will be equal to 2 over 3. So we can say that v2 is either 0 or v2 is either 2 over 3. So how do we get our v1? How do we get our v1? So if you substitute this value of v2 in any of the equations, for example, if you say using equation 1, we have 1 minus 1 equal to v1 plus 2v2. Is that right? So our v2 here is 2 over 3. So we'll say 1 equal to v1 plus 2 times 2 over 3. Is that right? So we have substituted the value of this. So we can now say that 1 equal to v1 plus 4 all over 3. And by the time we take this to the other side, it becomes what? Minus. So v1 is equal to 1 minus 4 over 3. Is that right? So if you do that, this is going to give us a negative answer. What is the LCM? 3. 3 into this, 1 times this is 4, minus this is 3, and this will give us minus 1 over 3. So v1 is equal to minus 1 over 3. Is that right? So yes. So v1 is equal to minus 1 over 3. So why the minus? Why the minus? It means that m1 will bounce back after